This video is going to talk about shell method. Shell method fundamentally is a little bit different than either disk or washer method. Disk method, your volume elements involved little cylinders with cross-sectional area of pi r squared and then a thickness of dx or dy, in this case dx. Washer method involved rotating and ending up with hollowed out cylinders, or aka washers, where your little volume elements were pi big R squared minus pi little r squared, all multiplied by some d whatever, in this case dx. Shell method is going to work a little differently. The way shell method works is, let's say this is my volume of rotation. Instead of using disks that are perpendicular to the x-axis, I'll end up using shells that are perpendicular to the y-axis. So this represents a little tiny shell. You could think of this as a roll of toilet paper that's slowly being built up, and you're looking at one particular sheet here. That particular sheet has a radius r and a height h. And if you unfurl that particular sheet, if you look edge on at that sheet, that has a thickness of dy in this case. So your volume of that particular sheet, this circumference, 2 pi r, this height, h, and some thickness equal to dx or dy. Now, one of the things you do have to remember with shell method is that dx or dy is reverse of disk and washer method. Here, this was parallel to the x-axis. It was the x-axis. Parallel to the x-axis, because of the way this rolls this way instead of is sliced this way, if we look at that edge on, that is a thickness dy. If it's parallel to the y-axis, we end up with dx. So really quickly, if I have this shape again, where this was rotated about the y-axis instead of the x, my sheets are instead looking like this. So you can imagine that roll of toilet paper being filled out with that little indentation in there. And so if you take one particular sheet, this is your r, this is your height, you look edge on, that sheet is that thick, that is a dx. So rotated about the y-axis in this case, we end up with dx. Now, shell method tends to be a little bit more complicated as far as carefully determining your r's and h's, or at least as complicated. Because you're determining both r and h, you have to be a little bit careful sometimes. However, there are some integrals that you have to do using shell method that you cannot do using disk and washer method because the function can't be inverted. We'll start though with a fairly simple one. Let's go with this one. So again, this is y equals square root of x, rotated about the x-axis from 0 to 4. And instead of drawing my disk, I'm going to draw my shell. Sorry, my shell goes like this. So my r would be here, my height would be here. Remember that's going to be volume of 2 pi r h d something. So it's rotated about the x-axis, so we know it's going to be dy. R is here, so by definition, if I'm going from the axis up to the curve, point on the curve, that is y. Factor out the 2 pi. So r is y. The height here is related to this distance, which is x, and this distance, which is a fixed amount, 4. So the height here ends up being 4 minus x. Notice I'm writing 4 minus x to keep it positive. You could get away with negative distances in disk and washer method because your r was always going to be squared and you would never end up with a negative number once you integrated. In this case, because r and h are not squared, you probably should be a little more careful just because it looks kind of bad if you get negative your correct answer. I mean, you could figure out that it should be a positive value for volume, but it just sort of looks bad if you use it looks bad in both cases if you use negative distances, but you kind of pay for it a little bit more in shell method. So we have this integral. Remember, our bounds have to be in terms of y. If this is from 0 to 4 in x, that's going to be 0 to 2 in y for y equals square root of x. But we have to get x in terms of y. So x equals y squared. We plug that in. We multiply that out and integrate. That's just power rule. Now let's see if we can find an example of a problem that can't be solved using disk or washer, but has to be solved using shell. Pause here. And I'm back, and I found a question. This is actually an example taken from Stewart. So let's say I'm trying to find the volume of this area rotated, where the function is y is equal to 2x squared minus x cubed above the between that curve and y equals 0. And I'm rotating it about the y-axis. So I need to spin this around. I end up with some, basically like a bundt cake shape. Now, could I do this using shell method? Well, using a washer method. So y equals 0 is my axis of rotation. Let's say I tried doing this. I'm going to run into some problems. First of all, if I attempted doing this using washer method, this would be my big R and this would be my little r. I have to find a way of splitting this curve up, which for certain functions isn't too bad, but it is going to be a bit of work. The bigger issue is that this big R is going to be x for this portion of the curve, and little r would be x for this portion of the curve. Now, I'm going to have a problem because how do I solve this for x? There might be some sort of weird factoring trick I can do, but off the top of my head, I don't know how to do that. Not every function is invertible. Y equals square root of x is invertible pretty easily. Y equals e to the x, pretty easy to invert that. X equals ln y. But some functions are not necessarily invertible. And so I run into an issue, right? Because my big R is x equals what? And then my little r equals x equals what? Something presumably different. It's not going to work. So I'm stuck using shell method for this one. What does it look like? Well, let me redraw the shape. Reminder, y equals 2x squared minus x cubed. So I'm rotating it this way. And so instead of it being a washer this way, it's going to be a sheet of toilet paper. And so this is my R, and this is my height of that piece of toilet paper. Let's also get our bounds in x. So if I factor out an x squared, that's going to be 0, that's going to be 2. Now it's rotated about the y-axis. Remember, that's going to be dx. It would be dy if it were disk or washer, but it's reversed for shell, dx. Because again, that little thickness, dx. So my volume is going to be 2 pi integral of RH dx in this case. R, going from the axis to the point on the curve, that's x. Height, going from The x-axis up to the point of the curve, that's just y. And I'm able to replace y as a function of x. My bounds are from 0 to 2, because it's in terms of x. So something that was impossible to do using disk and washer method actually becomes possible and fairly easy to do using shell method. Sorry, that's a dx. So hopefully this makes the case for using shell method, at least in certain situations. When you can't invert your function to get everything in terms of the correct variable. Or perhaps when you have to split a function into two pieces, perhaps a positive and negative piece. Even if it's possible, like in the case of a parabola, it may just be easier to use shell method. If I had a parabola that looked like this, yeah, I could figure out what big R is and little r is in terms of the roots. Right? If this is 4x minus x squared, I could solve that for x. I can complete the square. Let me do this a little more formally. Add 4 to both sides. Square root both sides. I could figure out x equals 2 plus or minus root 4 minus y. And this would be x equals 2 plus root 4 minus y. This would be x equals 2 minus root 4 minus y. So I could do this. And so my volume would end up being, in terms of y, because this is going up to, when x is 2, that's going to be 8 minus 4 is 4. So I could do big R squared minus little r squared. And yeah, after you FOIL that out, it's doable. It's a little bit annoying. You don't get quite as much cancellation as you hope for. It's powerful, but you got to worry about the negative y. It's doable. It's going to take a while. But what if I had used shell method? What's r? R is just going to the curve. That's x. What's height? Height's just y. And so, because this is rotated about the y-axis, I use dx. It's going from 0 to 4 in x. R is x. Height, because this is dx, I want to replace y. I just use my expression. Again, this is super easy to do using shell method. It's an example of one where even if it's doable using washer method, because you have to split up your function and you have to invert it, it's a pain. Try using shell method. Okay, hope this helps.